This is the Mechanics Homework Booklet, question 18. The graph represents the motion of two cars, A and B, as they move along a straight horizontal road. So you should begin by looking at the axes first of all, and you'll notice you have a speed against time graph. The first part of the question asks you to describe the motion of each car as shown on the graph. So fairly straightforward. Looking at car A, you see that it travels at a constant speed. You could even give the value of 16 meters per second. Car B, however, has two stages for its motion, so you must comment on each one. So first of all, the car accelerates for 5 seconds, and you know, because this part of the graph is a straight line, that it must be constant acceleration. It accelerates up to a value of 18 meters per second. After 5 seconds, it then travels at constant speed. Do use the graph effectively. The parts shown in brackets were not absolutely required for full marks, but mark schemes do change from time to time, and some quantitative information was required. Next, you're asked to calculate the distance travelled by each car during the first 5 seconds. So car A is very straightforward. It's just a matter of using the equation distance is speed times time. So careful substitution leads you to an answer of 80 metres. Now car B had a changing speed during the first 5 seconds. So you could think of it as average speed times time, since we had constant acceleration, or you could relate it to the equation of motion S equals a half U plus VT. In practice, this is giving you the average speed, since you are using half of the sum of the initial plus the final speeds. You're then multiplying by time, and it gives you an answer of 80 metres. Now you would be perfectly correct to state that the distance travelled can be found using the area under the graph, and this is often worth a mark on mark schemes. But you must take a look here and be very careful if you're using this method on this occasion, because the y-axis begins at 10. Clearly, if you're working out the area under the graph for this section, you must continue all the way down to the 0 for speed. Otherwise, marking an axis at a different value would give you a completely different answer, which doesn't make sense. So watch out, if using area under the graph, that you don't just count squares without looking at where the axis has started. In the final part of the question, you are asked to think about the two cars and relate their motion to each other. So at time t equals 0, you're told the two cars are level. And you're asked to explain why car A is at its maximum distance ahead of B at t equals 2.5. I'll take you back to the graph whilst thinking about this answer. So you need to think about the different stages of the journey and think about the separation of the two cars. So at the start, you're told they are level. However, it's worth noting that car A is travelling faster than car B. Therefore, A is going to get ahead, and the distance apart of the two vehicles is going to increase. That distance apart will increase until we reach the time of 2.5 seconds. At this instant, A and B have the same speed. After 2.5 seconds, however, car B is faster than car A. This means that the separation that had grown previously is now going to decrease. As a result, the maximum separation must correspond to the time of 2.5 seconds. I've summarised those points below for you to read at your leisure.